Question number 16, we are told the length of a shadow of a mast was measured at intervals of 1 hour and recorded as shown below. So we have time 0 hour at the starting point, that is 0, it was 18.7 meters. After 1 hour it was 8.7, like that up to the fifth hour, the length became again 0. So looking at on the grid provided, draw the graph of length against time, and you get 2 marks. So our graph is already labeled the vertical and horizontal axis. If you look at the scale, the vertical scale, 10 small squares represent 5, so it means 1 small square, 2 small squares represent 1. So for 0, the starting point, 8, we get 18.7. So this is 16, 17, 18. So 18.7, we approximate it is somewhere here. So that is where we put our mark. We come to 1, it is 8.7. So this is 6, 7, 8. 8.7 we approximate there. 2, it is 5, so that is where we have 5. 3, we have 2.9, so this is 1, 2, 2.9, we approximate somewhere there. And we have 4, it is 1.3, so this is 1, 1.3, we approximate there. And we have 5, the shadow length was 0. So we join these points to come up with a graph that represent length against time. So this is a graph that represent the length against time, and there you get 2 marks. Then determine the rate of change of the shadow length at t is equals to 2. So what we need here is to draw a tangent touching the curve at t is equals to 2, and we calculate the gradient. So this is the tangent that I have drawn touching at 2. So if we take this point, we can take the point of 9 and 0. And we take the other one is not, that is we take 0 and 9, that is coordinates 0 and 9, and we also take the point 4 and 0. If we get the gradient to change in y, we can say 9 minus 0 divided by 4 minus 0, so that you'll be able to get that is 0 minus 4, and that will give us 9 divided by minus 4, which will give you around 2.25. So that is the rate at rate of the change of the shadow. There is an allowance, because even our graph is so concentrated, so we can say give an allowance of 0.05 to give us. So you need to make a smooth curve, that is the curve, and approximate as close as possible to get the tangent, so that you get the rate of change, which is represented by the gradient.